Hello, everyone, and welcome to another episode of the Virtual Ninja Show. My name is Andrew, and I'll be your host for today's session Defense in Depth with Azure Firewall and Azure Web Application Firewall. Zero Trust in Practice. Wow, quite a mouthful. Joining me is my colleague Sai Prasanna, who will help us unpack how these two Azure services work together to build layered protection for modern applications. Sai, welcome to the show. Please introduce yourself.
Sure. Hi, everyone. My name is Sai Kishore. I'm a product manager in the Azure Network Security CXC CAT team. Thank you for having me on the show again, Andrew. I'm really looking forward to discuss defense in depth with Azure WAF and Firewall today.
Okay, awesome. Nice to have you, Sai. So, to start us off, what does defense in depth mean in the context of cloud security?
Sure. Defense in depth is the idea that you should have multiple layers of defense to protect your assets and not rely on a single layer of security layer. So, when you have a single layer of security, the attack surface is really vast, and that would give a lot of entry points for attackers to exploit. Therefore, it's a good idea to have multiple layered defenses to protect your assets. So, in Azure, for example, you can have firewall. In the talking about the networks perspective, you can have firewall to protect your network layer, protect from network layer threats, and then you can have Azure WAF for protecting you from application layer threats. So together, they're able to provide a comprehensive defense in depth type of security for your assets.
Okay, that sounds great. So now you've mentioned about the layered defense. So does Azure Firewall, how do Azure Firewall and Azure WAF complement each other in practice in the real world?
Sure. Azure Firewall and WAF work at different layers of the OSI stack. So Azure Firewall works at layer 4 of the OSI stack, which is the network layer. It also provides layer 3 to layer 7 protection and for both inbound and outbound traffic. Whereas Azure WAF, on the other hand, provides deep inspection of layer 7 traffic against layer 7 related threats such as SQL injection, cross-site scripting, bot attacks, and much more. So let's say Azure Firewall will will decide who is allowed into your network, whereas Azure WAF will decide what they can say. So together, they're able to provide a comprehensive defense in depth kind of architecture. That's why they're both able to complement each other and do this for your environment.
So why is this combination so critical for implementing a zero trust architecture?
So when you were talking about zero trust, one of the main principles of zero trust is never trust, always verify. So in that context, Azure Firewall is able to verify traffic or users in various ways using IPs, ports, protocols, and FTDNs and much more. And it's also able to provide you network segmentation to avoid any lateral movement of a breach, and it's also able to inspect and filter traffic both inbound and outbound using its IDPS and threat intelligence, therefore it can also avoid any kind of exfiltration. And when you're referring to Azure WAF, it's able to filter every HTTPS request using its rule sets, as well as provide geo-based or client IP-based, filtering for traffic if you configured it in your custom rules. So, thus, it really embodies the zero trust principles, which are verify explicitly, use least privilege, and assume breach.
Okay. So can you share any real world deployment scenarios where both are used together?
Sure, Nigel. So I think let's take an example of a web application. So let's say I have an architecture of an application gateway at the edge with WAF, and then behind it I have a firewall, and behind that I have a backend subnet with the web app that I'm referring to. So now in this scenario, traffic gets to the application gateway with WAF, and WAF is able to filter this traffic for any layer 7 based attacks. And then once that traffic is clean, it will send that traffic back to the firewall, which is right behind it, using a UDR. And the firewall now inspects this traffic for layers 3 to 7 applies IDPS and network segmentation, etc., and then sends this traffic back to the actual backend. Again, cleaning this traffic, making sure it's clean, and then now that's the inbound. Now for outbound, the backend subnet has a UDR to push all traffic for the internet to the firewall. So now the outbound traffic also gets inspected and filtered by the firewall. The firewall is also able to inspect east-west traffic. So this way, all the traffic from the edge to the backend and vice versa is being cleaned out and inspected for any kind of threats and attacks. So that's an example which we will also be showcasing soon in a demo.
And now that we've talked about deployment, so within deployments, of course, we have the architectures. So what does like a recommended architecture look like when integrating both of them together, Azure Firewall and Azure Web Application Firewall?
Sure. I think the recommended architecture would be definitely based on the use case of the customer. But let's talk about a few common scenarios, which includes app gateway and WAF firewall here. So first, let's talk about having the app gateway WAF and firewall in parallel. So this is a common scenario as well when you want WAF to be able to inspect inbound layer 7 traffic only, and you want firewall to inspect all the other traffic and outbound traffic. This is a good way to set it up. Another setup would be to have app gateway at the edge and then firewall behind it. This is the one we just referred to. So this is really helpful if you want a traffic to be inspected by both uh, app gateways WAS for layer 7 traffic as well as Azure Firewall's IDPS. This is really helpful in that scenario, as well as if you want end-to-end SSL and firewalls outbound TLS inspection as well. Another way to set it up is having Azure Firewall at the edge and having App Gateway behind it. This is really helpful if you want Azure Firewall to first be able to filter for network traffic, and then uh, also if you want to use the same IP for both inbound and outbound traffic. So these are some common scenarios, and what a customer needs to use would be dependent on their use case, their requirements, etc.
Okay, wow, that's a great rundown of the scenarios and architecture. Thanks for that. Now, to shift gears a bit, just to ask, how do these services help mitigate modern threats like ransomware or bot attacks?
So, Azure WAF itself is able to help you defend from layer 7 threats such as XSS, cross-site scripting, all the OWASP top 10. And these are sometimes related to, the initial access for ransomware. So, Azure WAF is able to protect you from these attacks, whereas Azure's bot manager rule set is able to protect you from malicious bots. It's able to differentiate between good, bad, and unknown bots, and it's able to block malicious bots. So coming to Firewall, Firewall is able to use its signature-based IDPS to block ransomware-related command and control traffic, and also help you with any kind of lateral movement of this breach. So by also filtering outbound traffic, Azure Firewall helps you prevent exfiltration. So together they reduce the attack surface and stop lateral movement within the network as well.
Okay, sounds good. So we know both of these services run in the cloud, and we have a lot of automation in the cloud. So maybe what role does automation play, in maintaining a strong defense in depth posture?
Sure, I think automation is very important, and few of the things it can help you with, maintaining a strong security posture is, probably using Azure Policy to enforce compliance configuration, and then you could also use a Sentinel to playbooks or logic apps to kind of block IPs that WAF detects. And then you can use managed rule updates for the WAF, and you can use firewall rule updates. That's automatically done to keep up with the updated threat landscape. So these are a few things, and you can also tap into Security Copilot, which is AI driven for investigation and threat response. So these are a few automation related, things you can do to really keep your defenses under control.
Okay, that's a good rundown of automation. So shifting gears again, to ask, what do you see? What are some common maybe mistakes or challenges that customers might make when implementing both services, and how can they avoid them?
I think a few mistakes that customers could make are, first of all, treating Azure WAF and Firewall as a completely different silos. Instead, I would rather see them as integrated layers that can protect you together. And um, one more would be maybe enabling WAF in prevention mode without tuning it first. So that would cause false positives. And not really enabling diagnostic logs, and not using CM Sentinel solutions, which are really helpful. So not taking advantage of those. So these are some common mistakes I would see, and I really hope they're able to take advantage of all of these options that we have.
Okay, that sounds good. Thanks for the tips. So how can organizations monitor threats when they're using these two solutions?
So for monitoring, definitely the first thing would be is to send diagnostic logs to Azure Monitor, or Log Analytics workspace, and use that to be able to kind of go back and look into the logs using SQL queries and things like that. And then you can also use WAF workbooks, which are really helpful in showing you a summarized view of your traffic that's being blocked so far and attack trends, etc. And more ways are using Sentinel CM solutions, even to correlate these two services together and understand what they're both blocking. Maybe VAT is blocking something at the application layer, and the similar attack is being happening at the network layer. So kind of useful really to correlate these attacks as well. And lastly, Security Copilot is really helpful. It's integrated into WAF and Firewall both, so you can query, the Security Copilot for things like show me the top few attacks, show me the IDPS catches that has happened, or show me the cross-site scripting attack that's happening, and it'll answer you by saving you a lot of time and investigation. So these are some things I think we can really use for monitoring and troubleshooting.
Okay, well, that's a great summary. So just to also maybe summarize, how have you seen customers benefit after implementing both Azure Firewall and Azure WAF together?
Of course, customers really benefit from it. Some of the things that that they can see immediately, they have a comprehensive security, because a firewall is doing both inbound, outbound inspection of traffic. It's doing layer 3 to layer 7 inspection, and it's also doing network segmentation. Firewall is also doing outbound traffic inspection using its IDPS, threat intel, and at the same time, it's also doing east-west traffic inspection. Whereas BRAF is doing really deep layer 7 inspection. So together, customers are able to get inbound, outbound, and different layered protection. And this really embodies defense in depth for us, and it really improves your compliance and visibility into the attacks. And it also provides end-to-end TLS if that's a requirement. Firewall is able to provide you outbound TLS. So these are some advantages. So ultimately, you'll be embodying zero trust, defense in depth kind of architectures here using these services. So I would highly recommend that you layer your architecture with these two services to protect your assets.
Thanks, Sai. Those are very fantastic insights. Thank you for walking us through how Azure Firewall and Azure WAF work together to put zero trust into practice. Now that we've covered the concept, let's see what it looks like in action. Sai, can you walk us through a demo?
Sure, I can walk through a demo showing a few attacks and how WAF and Firewall are going to protect us from them. So first, this is the architecture we are working off. As mentioned previously, this is this is where we have the app gateway with the edge and then firewall behind it. And then behind that, we have our Azure VM, which has a web app that we're going to be trying to reach this web app. And we're going to reach this web app via both the application gateway IP as well as the firewall IP. So when we reach it via the application gateway IP address, it'll hit both application gateway and the firewall premium before it reaches the backend, which is a juice shop web app that I had. But when we reach it through the firewall, it's going to directly hit the backend via the firewall and not really go through the web. So doing this, we kind of understand how these two services work individually and together to protect us from some attacks that we're going to try out.
Okay, Sai, just wanted to pop in for a quick question. So I'm seeing like based on this architecture of both WAF and firewall being used together. Are there like scenarios, like in real world scenarios where we have WAF stopping an attack, which is not being stopped by firewall? And if so, can you be able to showcase for us maybe that type of attack that WAF can stop? And I know more specifically, this will be at layer 7.
Sure. This is a juice shop that I have. So this 172 IP here is the application gateway IP, which goes to the web application firewall. And this is the other IP, which goes through the firewall directly and does not go through the app gateway. So now let's start with our first attack here. So I'm going to do a quick SQL injection attack. Okay. So here we go. So now I'm going to try to log in and I'm going to quickly insert an SQL injection based pattern here, which we'll see if that will trigger for us an SQL injection attempt and see how both WAF and firewall respond to this. So this is a layer 7 attack. So I want to see how WAF will respond to this. So I'm going to log in here. And as you can see, WAF has thrown us an immediate 403 forbidden, which means it's not allowing us to make this attack. Let's also try this on the firewall IP directly so we don't pass through the WAF. So I'm going to insert the same SQL injection pattern, which ideally, if it works, would give us admin rights. That's kind of how this attack works. So I'm going to log in using this. And as you can see here, we are immediately given the admin rights. I can see the orders payment. I can see that I have the admin rights and I've logged into this website. So using firewall, this layer 7 attack, which is hidden in the body, is not completely, it wasn't able to catch it, whereas the WAF was able to catch this attack. So that's a difference. We can see how with layer 7, WAF does much more deeper inspection. But at the same time, firewall catches that WAF may or may not do. We'll also look into that. Before that, I'll also showcase a few things that WAF is able to do using its custom rules that we discussed about. So as you can see, let's use WAF to understand how it's also able to help us with some custom rules, like we discussed in our, we discussed so far about how it can protect us using geo-based rules or any kind of custom rules. So we're gonna look at one of those right now. So let me go to this page. So just gonna quickly look at the custom rules that I have. So if you see here, I have a rule for JS challenge. So as you can see, I have a match value of the path /FTP. And it says anytime I go to /FTP path, throw a JS challenge. So this is a custom rule that I have. You can also have other custom rules. I also have a rate limit rule at /login, which says if I go to /login and I try to go to this website or this path multiple times, that is 10 times. That's what I have, but you can configure it, as many as you want. And then you can group it using client address, geolocation, and many other options. So that's kind of what I have. As I mentioned, you can have many types of match types, many types of occurrence match variables you can have. So let's go ahead and check how this is going to look and see if it's going to do this. So when I go to the About Us page and click on this, check out the terms, as you can see, there was a quick JS challenge that happened. So this was the /FTP page. So as you can see, this is a /FTP. That's why it threw us a JS challenge, which is checking us if you're a real user or a malicious bot. So, and all this happened, the browser was able to take care of this challenge in the background. So that's an example of a custom rule and how you can use that. And another one was to use it at the login page. So now if I go to login and I try to use regular password and I log in, it just says invalid email or password. So, but if I try to log in maybe about 10 times, you can see there was a 4034 billion right here, which is throwing us a challenge because the same client IP is trying to get to this WAF more than 10 times. So these are some examples of how you can use the custom rules of WAF.
Okay, Sai, that was great. That was a great showcase of WAF stopping inbound attacks. Do you have a similar scenario where also Azure Firewall is able to stop an attack that maybe bypassed the WAF? Just again to show the value of having both together.
Sure, we can definitely look into an attack which is a path traversal or information disclosure attack and see how Azure Firewall is able to catch that, when it's in line with WAF, but WAF will not be able to catch it. So that's one scenario we can definitely look into. So next, let's check out a few more attacks. I'm gonna go through the application gateway here, and I'm going to see how it's going to help us with a few more attacks. So let's insert another attack, which is a path traversal attack or information disclosure attempt. So this is /etc password. And when I insert this into the path and I try to get to it, so as you notice so far, Azure WAF throws a 403 error whenever it's denying us access. But Azure Firewall will time out and eventually give us a 504 whenever it's dropping any kind of traffic. So since here we are going to the application gateway, if application gateway, and we're also going to the firewall when we're going through this 172 IP address. And let's see how it's going to react to this attack. As you can see, I'm not able to get to this backend when I insert this parameters here. So we're not getting a 403 because the WAF is not blocking this traffic, but at the same time, Azure Firewall is not letting us through to the backend. That is why you're getting this timeout. But you would see that you'll get a timeout 504 timeout right now in a few seconds. That's because the firewall is dropping this traffic. So you can see that you're getting a 504 gateway timeout. So if we go back to our log analytics where we have our logs, let's take a look here. So let's first take a look at the Azure WAF and how it's blocking us from all of these attacks that we're doing. So as you can see, it's blocked us, rate limiting for this particular login. It's also blocked us from the other attacks that we've done. So with respect to the firewall usually takes a couple of minutes to find this. So let's give it a few minutes. Okay, so here we go. We can see how firewall was able to catch this /etc password attack, which the WAF was not able to catch. So this is a kind of where we're talking about having layered security, where even if one of the layers doesn't catch it, the other is able to catch it. And this is true for both layer 7, layer 4 traffic as well.
Perfect. So that was a great demo and definitely shows us the value of having both WAF and firewall. So what I've seen is that this is mostly for inbound scenarios where we've been stopping attacks trying
That's
to
right.
coming into environment. How about maybe outbound traffic originating from Azure or from within a customer's environment? Are we also able to secure that?
Of course, that's one of the main use case of Azure Firewall. So why don't we go see how Azure Firewall is going to help us defend from outbound attacks when we initiate traffic from the virtual machine that's behind it. Let's take a look at that. So I'm going to go ahead and I'm going to log into this virtual machine right here, which is behind the firewall. And I've already logged into it using Bastion here. So as you can see, this is a virtual machine. And I'm going to quickly check if the connectivity is up and running by connecting to bing.com. So I'm going to do a quick curl to bing.com. As you can see the verbiage, we are able to connect to bing.com. That's why you can see all of that verbiage there. So now I'm going to insert into the same bing.com connection, I'm going to insert Haxoman, which is a user agent and which is considered malicious. So I'm going to insert that and see if you're able to connect. So now from behind the VN, it's going to the firewall, which is going to apply its IDPS and threat intel. So let's see. So when I try to connect, as you can see, we're not able to connect using this specific user agent. That is because this user agent is malicious and our Azure Firewall was able to catch it. We can go back to the logs in a few minutes after we finish our testing and see, how we can find it. So I'm going to just get away from it because we won't be able to finish that connection. I'm also going to do another connectivity to this specific FQDN, which is test malicious domain, which is a test FQDN which will be dropped because threat intelligence will identify this FQDN as malicious. So let's try to connect to this specific FQDN. And as you can see, once again, we're not able to connect to it. And we can again check our logs and we'll find that the threat intelligence will identify this and drop this traffic as malicious. Okay, so that's one more use case. One last one I want to do is use iCar. It's a virus that a lot of antivirus companies use it for testing purposes. So if I try to download this file, it will be downloaded because this signature is alert only. So we can see this text file, iCar text file has been downloaded, but you can go back to the logs and we can see that this will be identified as a IDPS alert as well. So here we can see how Azure Firewall is identifying these, all of these outbound attacks. Let's just validate that by looking at the results so far. So you can see that it's caught this suspicious user agent Hexaman, potentially bad traffic. So IDS has caught that. So that's one example. So let's see if it's able to show us. So I'm going to just go a little forward in time so we can look at the other ones because I did this testing a while back. So I also did an Nmap test a while, Nmap scan a while back, and you can see how the firewall. So Nmap is a layer 3, layer 4 attack. So you can see how firewall has caught this because if traffic is coming on a non-standard port, which the WAF will not be able to catch because this is RDP traffic, and WAF only can catch the HTTP, HTTPS traffic. And let's see. All right, you can see here how iCar test file string, it's caught that. And you can see it's only in alert that we're able to download it, but it's able to identify that iCar file is being downloaded. So that's a few examples of how, firewall is able to catch both inbound and outbound traffic. We can also take a quick look at the firewall itself and see how, it has all of the other features that we discussed, which are the DNAT rules, which will help you protect from allowing all of the traffic and really filter out which traffic you can allow inbound. You can use these network rules for segmentation, for allowing traffic based on IPs, ports, protocols, etc. And then you have application rules, which you can use for filtering traffic based on FQDN, web categories, URL categories, and so these are a few examples that we have. But I hope you understand how these services work to protect us from all of the attacks that's out there.
Awesome. That was a great demo. Thank you so much, Sai. Learned a lot, and thanks for running us through the scenarios, inbound, outbound, and also we saw how attacks can be blocked in either WAF or in firewall. So definitely, really reinforces what you are discussing about the layered defense depth. Thank you so much for the demo. And with that, also like to thank you for being our guests in this show today. Thank you so much, Sai, for coming over. And for everyone out there, thank you so much for tuning in and watching this episode. See you around. Have a great day. See you in the next episode.